Hello, today we are talking about generics in Rust. So you might have used generics before, maybe in Java, where you might be creating a function where you could use different types of data types, maybe integer and float at the same time. So in Rust, you could do the same. So here in the example, it is given for the i32, the first function, and the second function is for character. um, so it has created two different functions, and the implementation could be narrowed down, and the code could be less lengthier if you could just use one function for getting the largest in the character or i32. So the thing is done repeatedly, but we can solve that problem with generics. Okay, so let's just simply take this code, and I know I'm just copying and pasting in the tutorial, but I think you can just understand, and we will talk about the function anyways. Let's try to run this, and I am expecting error here, and why that might be that you could see here. um, so let's run it anyways, and we'll talk about that. Let's run this. So it is giving us consider restricting type parameter t. So we haven't implemented this trait to the type t, so we couldn't use for two or multiple types in the trait. So what can we do to solve that, and what exactly is just stopping us from using that? So let's read this. This is a trait, and we are going to talk about, okay, we will, and said that the body of largest won't work for all possible type t could be possible. Because we want to compare values of type t in the body, we can only use types whose value can be ordered to enable comparison, the standard library for CMP. Okay, so it is just checking the program, or the language itself is checking for the implementation of the function, as whether we could implement the feature for all kinds of types, that is t, because not every type will have a implicit order to it. So we can just explicitly tell the program that we know beforehand that we are using something that has order to it. So let's do CMP. Okay, and partial order, I think that is what we need here. Yeah, so by using this, we are explicitly well, the word is mouthful. Okay, the t will be or will have the order to it, so we can implement the function for all the types t. So we are saying that the t will have a partial order to it. This is a trait, and we'll discuss about trait. So let's run it anyways. Okay, so the value is 100, but if we remove this, then we'll get an error, because the program doesn't know explicitly as we have an order in the type t or not. So that is the first example. Now let's go to structs, where we could use the generics. So we could create by ourselves or just copy paste. Let's remove the code. Okay, let's create it. Struct point that will have a type t, and x will have type t, y will have type t. Okay, let's create a point now. Let p that is a point. We'll create this point x x is 10, y is 10. Let's implement the thread debug. Okay, derive debug, and let's print it. Print ln. We'll use the macro. Okay, let's do p. Let's check our code. Okay, expected one generic argument. Well, we used p explicitly, so I guess that is why it is asking for us. Well, that shouldn't be a problem here. Point, we have done the same. Point has derived implementation of debug, but this is intentionally ignored during dead code analysis. Okay, let's remove it anyways. So the error most likely is because the way the Rust does it. Well, it's the warning. So yeah, we have the values here, so the code was just fine. Sorry, the code was just running fine. The warning was above that we are not using the field x and y. Let's undo the change. Yeah, so I'm sorry again. So we are doing just fine there while we are using point p and we are using i32. So we could just use the explicit, we can just define explicitly, or the code will be ran with explicit type that will be found out by the program itself. So yeah, so that is using generics with struct. So that was a example, and here we have 5 and 4.0. so since 5 and 4.0 are not the same data type, but we have said that we are using only single type, that is t, and that is implemented for both x and y, that is t and t, but we are not doing the same while creating the struct here, or let's say the point here. So that is why we are getting an error. So we could just go above that and use multiple types by giving a comma and using some different names. Well, it is just a way to write, so you could write anything up here and give a reference up here. then we will be just fine. So we have type 1 and 4, that is fine. We have 5 and we have 4.0. It is, these are different kinds of data types, but still we will not have any errors. And finally the example is for enum, and most probably we have used the type option and result. And by the way, these are one of the important enums that you need to be familiar with while creating programs with Rust, because these things will come in handy a lot of times, and knowing beforehand will just help you. So the option type has t, and so if it has the value, then it will have under sum, and we can extract that the t value. If it doesn't, then we have none, so it might be enum in itself, which does not have any value at all. And we have a result that has two types, that is t and e. T means we have value that is with OK, and we have error that is with type E, that is error. And we can also create our own type of result or option. If you like to do that, you can just do that. But yeah, that is what you'd use with enum, and it is very similar as what we have used with struct. Method definition, so we could also use it with implementation. Okay, so so let's understand this code. You can surely write the code for yourself, but you can also see the code. I will describe it and you can do it for yourself. So we are implementing in point, and this has type t. So this does not mean that writing t will give an access to t up here. So we are explicitly saying that we have t here. Okay, then function x, reference to self, that is point, and t, so it will return a reference to itself, or the type of t. We do not have a type t explicitly anywhere in the global scope, but as we have written impt, it has given access to us the type t, so it will give a reference to type t, and it is returning a value of x, that will be this value, which we might create. So exactly talking, this value will be returned up here. So yeah, and we can talk all day long about how we could implement and how you could mess up the program in Rust, because it is very easy to do that, as it is a little complex than what you might be used to. So more or less this is all about generics in Rust, and you can just look out for yourself in the docs and understand more about it. So I think this video is just finished now, and so I guess we'll see in another video. And if you like this video, please do not forget to subscribe this channel, and please support this channel. Okay then, bye.